Hello everyone, welcome to the channel Vidyutyo. In this video, we'll discuss about maximum power transfer theorem and we try to understand this theorem with the help of the simple solved examples. So before starting the video, those who are new to this channel, I request please subscribe the channel so that you will get updates about latest videos uploaded on this channel. Okay, regarding the maximum power transfer theorem, we know that many circuits basically consist of sources supplying voltage, current, or power to the load. For example, a radio speaker system or a microphone supplying the input signal to voltage preamplifier. So sometimes it is necessary to transfer the maximum voltage, current, or power from the source to the load. For example, if we consider the simple resistive circuit in which there is voltage source, then source resistance Rs and variable load resistance, that is RL, connected in series, then in such type of the simple resistive circuit, the source resistance is Rs. So our aim is to find the necessary condition so that maximum power will be delivered to the load. So in a fact, the maximum voltage is delivered to the load when load resistance is high compared to the resistance of the source. On the other hand, the maximum current is transferred to the load when the load resistance is small compared to the source resistance. So for many applications, an important consideration is the maximum power to the load. For example, maximum power transfer is desirable from the output amplifiers to the speaker of an audio sound system. So this condition for the transfer of maximum power is given by maximum power transfer theorem. So we'll discuss what is the statement of maximum power transfer theorem. So the statement is the maximum power transfer theorem states that maximum power is delivered from a source to the load when load resistance is equal to the source resistance. For example, if we consider this circuit, the maximum power is transferred to the load RL when Rs is equal to RL. Okay, so in exam there are generally two type of equation based on this theorem. Either there will be the derivation, that is derive the condition for maximum power transfer in a resistive circuit, or there might be the simple numericals are given which you have to solve with the help of the maximum power transfer theorem. So we have discussed about the statement. Now with the help of the derivation we will try to prove the statement when Rs is equal to RL, the maximum power will be transferred to the load. So for the derivation we will consider the simple resistive circuit in which voltage source is Vs, Rs is the source resistance, and RL is nothing but load resistance, and current I is flowing through this circuit. So power delivered to the load, that is RL, is given by the formula P is equal to I square into RL. Okay, but here for the current I can write down the formula P is equal to current I is nothing but Vs upon Rs plus RL, because this is the simple series circuit. So I square into RL, that means Vs upon Rs plus RL bracket square into RL. So I can write down the formula for power delivered to the load as P is equal to Vs square into RL upon Rs plus RL bracket square. Now we have to find out the condition at what condition the power delivered to the load, that is P, is maximum. So to determine the value of RL for maximum power to be transferred to the load, we have to set first derivative of above equation 1, that is this equation 1, with respect to RL, and we need to equate it to 0. That means we can say that we need to solve it for dp by drl is equal to 0. So here P is equal to Vs square into RL upon Rs plus RL bracket square. So dp by drl, that is first derivative of this power equation with respect to RL, is nothing but d by drl of Vs square RL upon Rs plus RL bracket square, and to find out the maximum power transfer condition we need to equate it to 0. So This is the formula like derivative of u upon phi. So what is the general formula for derivative of u upon phi? Phi derivative of u minus u derivative of phi upon v square. So here u is equal to v square RL and phi is rs plus RL bracket square. So what is the formula? V derivative of v. So phi is rs plus RL bracket square. Derivative of u, that is derivative of phi square RL with respect to RL is nothing but phi square minus u here phi square into RL, and derivative of phi, that is rs plus RL bracket square, derivative with respect to RL is 2 in bracket RL plus RL upon v square is equal to 0. So v is rs plus RL bracket square, so v square is rs plus RL raised to 4 is equal to 0. So when we'll solve it, it will become v square in bracket rs plus RL bracket square minus 2RL in bracket rs plus RL is equal to 0. So it will become rs plus RL bracket square minus 2RL into in bracket rs plus RL is equal to 0, which will become rs plus RL minus 2RL is equal to 0, that is rs is equal to RL. So maximum power will be transferred to the load when load resistance is equal to the source resistance. Thus we have derived the condition for maximum power transfer. But in this type of the theorem, whenever we have to solve the numerical, there is another one question: find out the maximum power transfer to the load. So here we need to obtain the formula for what is the maximum power transfer to the load. So here we can write, so calculation of the maximum power transfer, here Vs, that is source voltage, which is also given by Vth, which is also called as Thevenin's voltage. So Vs is replaced by Vth, then Rs, that is source resistance, is also called as Rth, that is Thevenin's equivalent resistance. Why it is denoted by Vth and Rth? Because while calculation of this Vs, the process is similar to the calculation of Vth, that is Thevenin's voltage source, and Rs is replaced by Rth because calculation of Rs is nothing but the procedure similar to the calculation of Thevenin's equivalent resistance. So Rth and RL are connected in series with Vth, and IL is current flowing through the load resistance. So Pmax is equal to IL square RL. So we can write IL is nothing but Vth upon Rth plus RL. So bracket square into RL. So any complex network can be converted with single voltage source. So source of Vth volt with equivalent resistance Rth in series with its RL using Thevenin's theorem across load terminal. So the variable resistance in such case must be equal to maximum power transferred to the load when Pmax is the formula Vth upon Rth plus RL bracket square RL, that is IL square into RL. But we know that what is the condition for maximum power transfer? Load resistance should be equal to the source resistance, that is in this case RL should be equal to Rth, and hence here we can write Pmax is equal to Vth bracket square upon, here we will replace RL by Rth. So Rth plus RL, it will become Rth plus Rth, that is 2 Rth bracket square into RL is replaced by Rth. So what is the formula? Vth square upon 4 Rth. That is the formula for maximum power transfer to the load is nothing but Pmax is equal to Vth square upon 4 Rth. Okay. So now we have discussed about the derivation, as well as we are having the formula for calculation of maximum power transfer. Okay. Now what are the general steps whenever we are going to solve any circuit by using the maximum power transfer theorem? First one, replace the given network across the load terminal by Thevenin's or Norton equivalent circuit. That is, we can also say that the calculation of Vth or IN and R equivalent. This is the first step. Second one, when RL is equal to R equivalent, gives the condition for maximum power transfer to the load. Third step, if magnitude of maximum power is asked, then only find it with the help of the formula. What is the formula we have derived? Pmax is equal to Vth square upon 4 into Rth. And if value of RL for maximum power transfer is asked, then also you can find out with the formula R equivalent is equal to Rth. At that time there is no need of calculation of Vth. Okay, so these are the general steps. Now we will clear our concept with the help of the simple solved numerical. So for example, this is the numerical in which there is 5 volt voltage source, 4 ohm resistance, 10 volt voltage source, then variable resistance is RL and 15 volt source is connected. And what is the question? Find the value of load resistance RL, that is this load resistance RL, for maximum power transfer and magnitude of maximum power dissipated in the resistance RL shown in figure. So what type of the numerical is there? Here we need to calculate the value of RL for maximum power transfer, as well as we need to calculate the value of maximum power transfer to the load. So what is the first step? First step is calculation of Vth, that is Thevenin's equivalent voltage. So what we do while calculation of the Thevenin's equivalent voltage? We replace the resistance, load resistance, with the help of the open circuit. So here we have drawn the same circuit, only change is that RL is replaced by open circuit, and the voltage across this open circuited terminal is nothing but Vth or VOC. So here Vth is shown, that means we have to find out the voltage across this open circuited terminal. So how we will solve this circuit? First of all, we will try to calculate the current I which is flowing here. So for that we will apply the KVL for this loop. So what is the equation? Minus 4I. Why minus? Because voltage drop we consider whenever we are going from positive to negative terminal, voltage drop is considered as a negative. So it is minus 4I. Here minus 4I. Then for the voltage, whenever we are going from positive to negative terminal, it will be considered as negative. So minus 10. And here we are going from in upward direction, that is negative to positive direction. So it will be plus 5. This voltage will be considered as plus 5. So minus 4I minus 10 plus 5 is equal to 0. When we will solve, we get I is equal to minus 5 by 8 ampere. So we got the value of I. Now for the loop 2, if we apply the KVL, then we'll start from here. Since we are going from in this direction for the considered loop, we are going from positive to negative. So minus Vth. Here we are coming in downward direction from positive to negative. So minus 15. Then here it will be plus 10. Okay, here current through the 8 ohm will be 0. That's why their voltage drop will not consider, because this is the open circuited terminal. That is plus 10 plus, because of this closed loop, the current is flowing through the 4 ohm, and that current will be 4 into I. So it will become minus Vth minus 5 plus 4 in bracket I is nothing but minus 5 by 8. So it is minus Vth minus 7.5 is equal to 0. That is Vth is equal to 7.5 volt. So we have calculated the value of Vth, okay, which is minus 7.5 volt. But while calculation we will consider 7.5 volt because we are interested in the magnitude only. What is the next step? Calculation of Rth. So for the Rth, what we do? We open circuit the terminals of load resistance. Then all the other sources are replaced by internal resistance. That is, voltage source is replaced by short circuit and current source is replaced by open circuit. But in this numerical, since all the voltage sources are given, that's why while calculation of equivalent resistance, that is Rth, RL will be open circuited, all the voltage sources are replaced by short circuit. Then the diagram will be replaced by this one. So 4 ohm, 8 ohm resistances are connected. Now we have to find out the equivalent resistance between these open circuited terminal. So solve the circuit from opposite side. That is, this 4 ohm and 4 ohm is connected in parallel. that is 4 ohm is parallel with 4 ohm, and that equivalent resistance is connected in series with 8 ohm, so plus 8 ohm. So 4 parallel to 4 2 plus 8, that is 10 ohm. That means RTH or R equivalent for this circuit is 8 ohm. So we are having the value of VTH 7.5 volt, we are having the value of RTH 10 ohm. What is the question? Find the value of load resistance for maximum power transfer theorem. So for the maximum power transfer theorem, RTH should be equal to RL. So that means the maximum power transfer the value of load resistance to transfer the maximum power is equal to RL is equal to RTH. What is the RTH? 10 ohm. So maximum power in this circuit will be transferred when RL is equal to 10 ohm. And what is the another sub question? Calculate the maximum power transferred value. So maximum power transfer is equal to VTH square upon 4 RTH. That is VTH is 7.5. So 7.5 square upon 4 into RTH 10. So it is 1.406 watt. 1.406 watt. So this is the one simple numerical. I think the concept is clear. If you are having any doubt, you can ask in the comment. Now second type of the question, like here the value of 50 volt is given, value of 25 ohm is given, which is nothing but RTH. This is VTH, and we need to find out the value of RL. So if the circuit shown determine the value of in the circuit shown determine the value of load resistance, that is RL, at which there is it draws maximum power. Also find the value of maximum power. So here if you are having the idea of maximum power transfer theorem, we can easily solve this numerical. Like the source delivers maximum power when load resistance is equal to the source resistance. That means whenever RL is equal to 25 ohm, RL is equal to RS. That is whenever RL is equal to 25 ohm, maximum power will be transferred to the load. And second one, current flowing through this circuit I is equal to VTH upon RTH plus RL. That is 50 upon 25 plus RL. So RL is 25, so 50 upon 50, that is 1 ampere. So maximum power delivered to the load is P is equal to I square RL. So I is 1 square into 25, that is 25 watt. Otherwise we can directly use the formula I is maximum power transferred P max is equal to VTH square upon 4 RTH. That is 50 square upon 25 into 25 into 4, so it will be 25 watt. Okay, so you can easily solve by any method. Now third type of the numerical. So in the network shown in figure, that is in which 15 volt 3 source is there, 3 ohm, 3 ohm, 1 ohm and 1 ohm, these resistances are connected, and there is variable load resistance is connected in across terminal A and B. What is the question? In the network shown in figure, first part of the numerical, find the value of RL such that maximum power will be transferred to the load, and second, find also the value of maximum power and power supplied by the source under this condition. So this is another one tricky question. The power supplied by the source. Okay, so always keep in mind that whenever there is the question like power supplied by the source, actually whenever we are going to calculate the maximum power transfer theorem or solve the maximum power transfer theorem, we consider such type of the circuit. It is, we convert the circuit into the simple equivalent circuit in which RS and RL connected in series. But for the maximum power transfer theorem, RS is equal to RL. Hence, power, if we calculate the power supply, maximum power supplied to the source, it is suppose I square RL, then same power will be dissipated in the this resistance, that is I square RS, because RS is equal to RL, and same current is flowing because there is a series circuit, and hence the power supplied by the source is nothing but power dissipated by the RS plus power dissipated by the RL. So if there is question like if you are having the idea about what is maximum power supplied to the load, then So power supplied by the source is nothing but 2 times of RL, 2 times of the power dissipated in the RL. I repeat, if you are having the idea about maximum power supplied to the load, that is RL, then power supplied by the source is nothing but 2 times of power which is supplied to the RL. Okay, so such type of the numerical is there. This last numerical. Here there is question, calculate the power supplied by the source under this condition. So first step is calculation of Vs or Vth. So what we do in this step, we will open the load terminals and we will try to find out the voltage across the open circuited terminal. So we will redraw this circuit with the only change is that RL will be removed by open circuit. So we need to find out the voltage across this open circuited terminal A and B. So what is the formula for Vth? Vth is equal to, Vth is nothing but, since this A and B are open circuited, Vth is nothing but voltage drop across 3 ohm. So what is the voltage drop across 3 ohm? Current flowing through the 3 ohm into 3. So what is the current flowing through this 3 ohm? If A and B are open circuited, 15 upon 3 plus 3 into 3. That is the voltage drop or Vth. So Vth is equal to 15 by 2, that is 7.5 volt. What is the second step? Calculation of RS or RTH or equivalent resistance. So in this case, we'll open circuit the load terminals A and B, and all other energy sources are replaced by internal resistance. That is, if voltage source is present, it will be replaced by short circuit, and if current source is present, it will be replaced by open circuit. So in this case, A and B are open circuited terminal and voltage source here is replaced by short circuit. So it will be 3 ohm parallel with 3 ohm, and remaining resistances are 2 ohm and 1 ohm. So solve from opposite sides. So 3 ohm is parallel with 3 ohm, that's 3 parallel to 3, and that equivalent will be in series with 2 and 1 ohm. So plus 2 plus 1. So RTH is equal to 4.5 ohm. Now we can draw the circuit for calculation of maximum power transfer theorem. So in which Vth is 7.5 volt, it is connected in series with RTH or RS, which is 4.5 ohm, and RL, variable RL, is connected in series with this. So what is the question? We need to find out the load resistance at which there is a maximum power will be transferred to the load. So as per the maximum power transfer theorem, maximum power is delivered to the load when RL is equal to RS, that is when RL is equal to 4.5 ohm. So this is the resistance at which there is a maximum power will be delivered to the load. What is the another sub question? B, calculate the maximum power drawn by the RL. So maximum power drawn by the RL, we are having the formula, that is, it is I square RL, or in term of these parameters, these equivalent circuit parameters, it will be Vth square upon 4 RTH. So Vth is 7.5, so 7.5 square upon 4 into RTH is 4.5, so it will be 3.125 watt. That means maximum power delivered to the load is 3.125 watt. But what is another question? Calculate power supplied by the source. So we have already discussed power supplied by the source is nothing but 2 times of maximum power delivered to the load. So it will be power supplied by the source is 2 into 3.125 watt, that is 6.250 watt. So only such type of the varieties you can observe if you refer the different reference book to solve the numericals based on the maximum power transfer theorem. So I repeat, the maximum power transfer theorem is nothing but the maximum power is delivered to the load when load resistance is equal to source resistance. Then you need to prepare the derivation for maximum power transfer theorem and for formula for maximum power delivered to the load. And third, you can solve the different numericals from the different reference book to solve any circuit with the help of the maximum power transfer theorem, in which first step is calculation of Vth or VOC or Vs, second step calculation of RTH or RL, RTH or RS, third step draw the equivalent circuit consist of 3 parameters, VTH, RTH and RL, and then calculate the value of RL for maximum power transfer with the statement maximum power is delivered to the load, then RTH is equal to RL. And whenever there is question like calculate the maximum power drawn, then it will be formula VTH square upon 4 RTH. And if there is question power calculate the power supplied by the source, then it will be 2 times of maximum power delivered to the load. Okay, I hope the concept is clear. I again request those who are new to this channel, please subscribe the channel so that you will get the updates about latest videos uploaded on this channel. So till then, bye bye, thank you, happy learning.